Today's lesson is on one-step equations. Equations are equivalent statements, like this time x is equal to 4. Or over here, 4x plus 1 gives me the same answer as 3x plus 5. And then here, 2x plus 4 is equal to 8. And down here, x divided by 4 is equal to 10. When they're referring to one-step equations, it's indicating how many steps it takes to solve for the variable. So that means that there's only one step to solve where a variable equals a number. Our main idea is, how do we undo what was done to a missing number? So for example, if I just say that n equals 8, then my variable already is isolated and I know that my solution is, my number that is missing is 8. If I say that my number plus 1 gives me 3, that's easy because I know that 2 plus 1 gives me 3. So my missing number of n must be 2. It gets a little more complicated once we start applying our fractions and decimals and integers. For example, a missing number plus 5 equals negative 10. Now some of you can use this substitution method and figure out what n must be for this to be true. But if not, we're going to use this undo strategy. So if some number, when I add 5, gives me negative 10, then to get back to that original number, I have to undo what was done. So instead of adding 5, I subtract 5. So when I have negative 10 subtract 5, that gives me negative 15. So my missing number must be negative 15, which works because if I add 5 to that, it gives me negative 10. This leads us to our vocabulary word of inverse operation. The inverse operation is how I'm isolating the variable, how I'm undoing what was done to x. So the inverse operation of subtraction is addition, and the inverse operation of multiplication is division, and vice versa. The inverse operation of addition is subtraction. The inverse operation of division is multiplication. Those are my undo operations. Here's our first example. Most of you would be able to use the substitution method and say, what number plus 8 gives me 12? Well, y must equal 4, which is technically correct. But we're going to use this very simple example to show you how inverse operations work. So if I have a y and 8 giving me 12, my inverse operation to adding 8 is to subtract it. If I subtract 8 on one side, that gives me 0, leaving me with y. But then I also have to subtract 8 on the other side, giving me a positive 4. Let's break down what I just did. First, I recognized I needed to isolate my variable by using my inverse operation. My inverse operation for adding 8 was to subtract 8. That got rid of that 8 that was around the y, and it left y to be isolated and all by itself on the left side of the equation, saying y equals something. But if we subtract 8 on one side, we have to do the same thing to the other side in order for it to stay equivalent. For example, we all know that 3 plus 2 gives us 5. So if I add 6 to one side, that's now going to give me 11. So I have to add 6 to the other side in order for it to stay equivalent. If I do it to one side of the equation, I have to do it to the other. Here's our second example. Some number divided by 4 is 3.3. So what's my inverse operation for division? Well, to undo division, I have to multiply. So what I do is I have the w divided by 4 equaling 3.3. So to undo that divide by 4, to use my inverse operation, I'm going to multiply by 4. And remember, if I multiply by 4 on one side, I have to do the same thing to the other side. And when I say the other side, I'm talking about the other side of that equal sign. Well, if I have some number divided by 4 and multiplied by 4, that division and multiplication are going to make 1 or cancel out. I'm left with w equals 13.2. For example 3, we have some number subtracted by 2/3 equals 1/4, which means we're working with fractions and adding and subtracting them. Now remember, when we're adding and subtracting fractions, we're going to need a common denominator. Our common denominator between 3 and 4 is going to be 12. So 3 goes into 12 4 times, and 2 times 4 gives me 8. And then 4 goes into 12 3 times, and 3 times 1 is 3. So really my equation is reading f subtract 2/3 is now 8/12 equals 1/4, which is 3/12. My inverse operation, so let's look, what's being done to f already? I have a minus 8/12. So my inverse operation is going to be to, not in highlighter, but in pen, is going to be to add 8/12. And remember, if I add it to one side, I have to add it as well to the other side. This gives me f equals 11/12 because we had already found those common denominators to start. Here's one for you to try on your own. Pause the video, try it, and then play and check your answer. If I have r plus 2.3 equals 7.1, my inverse operation for adding 2.3 is going to be to subtract 2 3/10. I'm left with r, and then 7.1 minus 2.3, or 7 1/10, minus 2 3/10 is going to give me 4 8/10 for r.